Climates, welcome to join me in learning the course Tea Processing. In our last session, we explored the quality characteristics of white tea. So, how is white tea processed? Let's take a look together. White tea processing technology. Traditional white tea processing involves simple steps without frying or rolling. The process can be summarized into two main steps: withering and drying. Withering is the key step in shaping the quality of white tea. The total withering duration ranges from 36 to 72 hours. During this prolonged withering, moisture slowly evaporates. Enzyme activity increases, and the internal components undergo slow and controlled changes, gradually forming the unique quality characteristics of white tea. Withering methods include indoor natural withering, compound withering, and artificial climate withering. Indoor natural withering is the most commonly used method for white tea. Compound withering alternates between sun withering and indoor natural withering, requiring large spaces and making it difficult to control the process. Artificial climate withering uses climate control equipment to simulate the optimal natural conditions for white tea withering. Drying methods include solar drying, air drying, and baking. Principles of white tea quality formation. The dry tea leaves of white tea exhibit a harmonious blend of green, yellow, and reddish hues. Dominated by green, they are interspersed with subtle yellow and red tones, all set against a backdrop of celery peco. This combination presents the characteristic white tea appearance: a grayish-green base with a lustrous silvery sheen. The formation of this dry tea color is the result of the interaction between pigments and polyphenolic compounds in the leaves. On one hand, during the withering process, chlorophyll and carotenoids are easily degraded, while xanthophylls remain relatively stable, altering the proportion of green and yellow hues in the leaves. On the other hand, during the prolonged withering process, the loss of moisture, changes in cell sap concentration, and increased cell permeability allow polyphenolic compounds to come into contact with polyphenol oxidase, leading to enzymatic oxidation and condensation. This forms yellow and red substances. The aroma of white tea is fresh and brisk, with a distinct hairy bud fragrance. The formation of this aroma is primarily due to the following changes during processing. In the early stage of withering, the evaporation of moisture from fresh leaves increases the concentration of internal components and enhances enzyme activity. Organic substances tend to hydrolyze, with starch and proteins breaking down into monosaccharides and amino acids. Polyphenolic compounds undergo enzymatic oxidation and condensation, creating favorable conditions for the formation of white tea's aroma. In the later stage of withering, enzyme activity gradually declines, and enzymatic oxidation is gradually replaced by non-enzymatic oxidation. Polyphenolic compounds interact with amino acids, and amino acids interact with sugars to form aromatic substances, which carry a grassy scent. The final baking step in white tea processing further transforms substances with grassy and astringent flavors. For example, cis-3-hexanol, which has a distinct grassy odor, undergoes isomerization to form trans-2-hexanol, which has a fragrant aroma. Amino acids undergo oxidase deamination under heat, forming aromatic aldehydes. The tea liquor of white tea is light and pale, with an apricot yellow color and a mellow, refreshing, and sweet taste. This is mainly due to the following reasons. Traditional white tea processing does not include a rolling step, so enzymes and polyphenolic compounds cannot fully interact, and oxygen supply is limited. Secondary oxidation proceeds slowly, making the tea liquor and taste of white tea less intense compared to other types of tea. Meanwhile, protein hydrolyzase produces amino acids that contribute to the umami taste. The content of amino acids increases as withering time prolongs. During the mid to late stages of withering, the slow and slight oxidation and condensation of tea polyphenols increase the amount of oxidation products, like orthoquinones. This significantly reduces the tea polyphenol content in primary tea, resulting in a mellow taste and an apricot yellow liquor. During the drying process, catechins are significantly reduced, eliminating the astringency of the tea liquor and making the taste even more refreshing and mellow. Through the study of the above content, we have gained a clear understanding of the principles behind white tea quality formation and the technical characteristics of its processing. That concludes our lesson for today. Goodbye, class.